So, hello world. I heard that it's not working well with the big blue button, so I'm going to explain you the ER dependent translation once again from here, YouTube video. It's part of chapter 15, how the translation starts. We know that all the translation, no matter what, no matter what, it's going to end up with either the plasma membrane or the mitochondria or the nucleus, they all start in the cytosol. So cytosolic translation is the default. But if it is going to go to nucleus, for example, it's going to finish translation in the cytosol, and then it's going to be transported to the nucleus via the nuclear import receptor. If it is going to be transported to mitochondria, it is going to be taken to mitochondria through transporters. But if it is going to enter into the endomembrane system, then it is going to start translation, or it's going to continue translation in the ER surface. So ER surface is the start point of endomembrane system. So wherever it's going to go in the endomembrane system, either ER or Golgi or vesicles or lysosome or the cell surface or to the extracellular site, it's going to start here right now. So here you see the mitochondria, the mRNA and the ribosome around it, and a little bit of polypeptide, little bit of protein is translated there. And right after it is translated, some localization signal emerges. So here, you can have a nuclear localization signal. Not nuclear, I'm sorry. ER start transfer signal. So this ER start transfer signal is going to be recognized by a particle called SRP. SRP is going to recognize this ER start signal and bring everything here. So the translation is not going to continue there in the cytosol, but here into the ER lumen, and the protein will continue translation into the ER lumen. So what is really going to happen is that, sorry, my mistake. So it is going to continue translation here. Of course, the ribosome will also be here, and the protein will continue here, this way. So this is the N terminus of the protein, and here it is continuous, so I can say this is the current C terminus. The ER start transfer signal is here. Of course, as the protein is being translated, it's going to stay there, but right after the protein translation finishes, this ER start transfer signal will be cut by an enzyme called signal peptidase. Okay, so at the end of the translation, what it is going to look like will be this. So let's say it's already folded. So N terminus here, C terminus here, and the ER start transfer signal is gone because it is cut by the signal peptidase. Okay, but that's not the only way. There are alternative versions. Of course, many things can happen. Now imagine that the ER start transfer signal didn't happen that way, but the ER start transfer signal started while it is already being translated a lot. So let's say the ER start transfer signal is here, why this is the N terminus. So it's not going to continue in the like in the previous case. So what it is going to look like is this. So this is the transporter. So this is the protein, and then it's going to look like this. The N-terminus will be here outside to the cytosol, and the C-terminus will be here inside the ER lumen. And unlike in the previous case, the ER start signal will stay attached here. It cannot be cut by the signal peptidase as it is here, because if it is cut, the protein will also be cut into two, and this cannot happen here because it's in the middle of the protein. And if you cut the ER start transfer signal, you're going to cut the protein into two, which you don't want. So in this case, the protein will not be an ER lumen protein like in this case. So this is a lumen protein, but in this case it is going to be a membrane protein. Okay, so if this protein, for example, continues to the endomembrane system, for example, if it reaches to the Golgi, you can find it in the Golgi. So it is going to be in the Golgi lumen, but it's never going to be a membrane protein. Or if it continues via exocytosis, if it reaches to the plasma membrane, it is going to be exocytosed, and next it is going to be outside the cell. So you're going to see it outside the cell in the extracellular site. And remember, anyway, the lumens, here the ER lumen, here the Golgi lumen, and here the extracellular site, they are continuous to each other, while cytosolic is always cytosolic. Okay, cytosolic surface never changes. And in this case, when it reaches to the Golgi, or when it reaches to the plasma membrane, it will always keep the orientation. So this is what it's going to look like. So here you see the N-terminus is in the cytosol. Again, the N-terminus will be in the cytosols, and the C-terminus will be in the lumen. And if it is transported to the plasma membrane, again, the cytosolic part will stay cytosolic. The N-terminus will be here, and the C-terminus will be outside to the cell. Of course, the ER start transfer signal will always stay attached here. Okay, this is the story of a single transmembrane protein, but it's possible that it is a multi-transmembrane protein. So maybe the ER start transfer signal is here. It's even cut as usual. And we have another signal here, ER stop transfer signal, which is another signal in this case. So I hope I'm going to get better in this drawing stuff. So ER start transfer signal is here, up. Soon this ER start transfer signal will be cut. This is the N-terminus. This is start transfer, and here you have another signal, which is the stop transfer. So if it continues this way, and if it is cut by the signal peptidase enzyme here, of course the other one, the stop transfer, will not be cut. This is what you're going to see. In this case, the N-terminus will be free here, because after the signal peptidase cuts it, the N-terminus will be stay available into the ER lumen, and the C-terminus, which is here, is going to be outside. And in the middle, you're going to see the ER stop transfer here. Signal is going to stay attached. It is not going to be deleted or something. And just like in the previous case, if it is transferred to Golgi or the plasma membrane, it will have the opposite orientation. Again, the C-terminus is cytosolic, so it will always be cytosolic. And here the C terminus is cytosolic and the N terminus will face to the extracellular environment. Okay, and this kind of transfer is very usual between the endomembrane system particles. Now let's see the story for how it happens for a multitransmembrane protein. Now imagine this time it has several start transfer and stop transfer signals. So let's say it started here with a start transfer signal, it stopped here with a stop transfer signal, and of course with the stop transfer signal, this mRNA plus the ribosome complex will not stay attached anymore. It's going to be free, wandering around. It will grow this way, and then when it encounters again another ER start transfer signal, it will come back. Okay? Oop. And then it will be free. So here it's the N terminus, C terminus. And here we have several parameters. This is the start transfer. This is the stop transfer. Again, there is another start transfer. Okay. The primary structure of this protein would look like this. N terminus, C terminus. So here there is a start signal, and this start signal should always happen. Any kind of endomembrane system protein should always start with the start transfer signal. It can be here at the beginning of the protein. In that case, it's going to be cut, so the N terminus will be localized. It's going to face inside the lumen, or it can be somewhere in the middle, which I'm going to show in the next case. So there is a stop transfer signal, and there is another start transfer signal. Okay, and finally the protein will look like this. Okay, because here it is cut with the signal peptidase. The N terminus here, C terminus here. The first start transfer signal is cut, so we don't see it anymore. The last two ones, the stop transfer signal and the start transfer signal, they are here attached. So it's a two transmembrane protein. Both the N terminus and C terminus stay attached. Okay, in an alternative case, maybe this start transfer signal doesn't emerge immediately into N terminus, but a little bit far away, a little bit downstream. So in that case, first it's going to stay outside and then start into the ER, stop, and then continue, and then come back. So here there are several signals. This is the N terminus, of course. This is the start transfer signal, which will not be cut. This is the stop transfer signal. This is the start transfer signal. And this is what the primary structure of the protein will look like. N terminus, C terminus. The first start transfer signal is not at the N terminus anymore. It's somewhere in the middle. So it will not be cut by the signal peptidase. Second, there is a stop transfer signal and another start transfer signal. And the final structure of the protein in the membrane would look like this. N terminus, C terminus. So the first start transfer is here, the stop transfer is here, the second start transfer is here. Of course, when this protein is exported to the plasma membrane, it's going to stay intact as a plasma membrane protein. This is what it will look like. The N terminus, the cytosolic part, will stay cytosolic, and the C terminus, which is the lumen part, here it is the lumen, is going to stay extracellular. Okay, so this is all for today. If you have another